of a line that is not vertical represents a function. Did you know all lines are function, except if it's vertical, then obviously it would fail the vertical line test, because it would have an infinite number of points that are intersecting that vertical line. We call these functions linear functions. We can use the intercepts to describe the graph of a linear function. Now, intercepts are where they cross either the x or the y axis. So if we're looking at this, you see the horizontal axis is your x. Sometimes it might be t, sometimes it might be whatever. But this graph intersects the horizontal axis at where? Yeah, at 2, 0, so that the horizontal intercept is 2. Notice it's a sept, not a set. Intersection is spelled differently, right? Intersection is spelled differently. This is an intercept because it intercepts the x-axis at 2, okay? The coordinates of this point are 2, 0. Okay, whatever. The graph intersects the vertical axis at, you see, 0, 5. So the vertical intercept is 5. The coordinates of this point are 0, 5. Does anybody notice something kind of characteristic of the intercepts? Yeah, if we're talking about the x-intercept, the other coordinate is 0. If we're talking about the y-intercept, the other coordinate is 0. So that's how we're going to actually figure these things out algebraically coming up. Okay, so we're going to find the intercepts, the domain, and the range. So here is a graph that shows a temperature and a location over a 12-hour period. We need to find the vertical and horizontal intercepts. So who can tell me the vertical intercepts or the y-intercept? Negative what? Negative 6. And what is the x-intercept? You got to watch the scale, right? 4. So when we talk about intercepts, we're talking about a value. Okay, when they want the coordinates at the intercepts, then you put the coordinate, okay? So we should actually put some units to this. What's minus 6? What is the units? Degrees Celsius, yeah. And what is the 4 hours? Yes? What's the domain and range? Domain and range. And I'm going to actually make a C. What is the rate of change? Whoops, I was going to say ROT, but ROC. So I'll give you a minute to find the domain, the range, and the ROC. Kaylin, what's the domain? No. So this is actually not an X. This would be a T as an element of reals. What does T have to be between? Anybody? 0 and 12. So can it equal? Yeah. So you have an equal sign after that. Okay, remember, domain, it means you scan left to right. Okay, so range, this is going to be C, right? So C is an element of reals. What is that between? Scan from bottom to the top. Yeah, negative 6 is less than or equal to C is less than or equal to 12. Everybody good with that? Is my rate of change positive or negative? Positive. It's going up to the right. Yes? Does anybody know what the rate of change is? The fraction, right? 3 over 2, yeah. Okay, so it doesn't matter where you do it. I would probably maybe do it from here to here. So this is measuring how much? 12, and this is measuring 8. So my rate of change would be so 12 over 8, which reduces to 3 over 2. And what would my units be? Yeah, degrees Celsius per hour. Does anybody know what that means? 3 over 2? You probably want to change that to 1.5, right? Then it makes more sense. This is for every hour, it changes 1.5 degrees Celsius. That's essentially what it's saying, right? Yeah? Okay, moving on. The graph shows a person's distance from the finish line for a bicycle race. What are the vertical and horizontal intercepts? What do they represent? Was I supposed to answer that on this last one? Oh, what do they represent? Well, we had, what does the negative 6 degrees Celsius represent? This actually represents the starting temperature, right? Does everybody see that's the starting temperature? And what does the 4 hours represent? It took 4 hours. 4 hours to get to freezing or to get to 0 degrees Celsius, yeah? Okay, so sorry. Rate of change, if it's going down to the right, would be negative. Very good. I'm going to do that as a C again, just so we have practice. Okay, so I'll give you a second to do A, B, and C. Okay, so if it's asking for a vertical intercept, that's your Y-intercept, or in this case, your D-intercept, right? So what would that be? 100 kilometers. And your T-intercept would be 5 hours. Are you guys remembering to put your units? What do they represent? Okay, I know it represents distance and time, so let's be a little bit more specific to this question. So this is a bicycle race. Yes, this represents 100 kilometers away from finish line at starting time. And what does the 5 hours represent? The time it took to finish? Yeah. Okay. So when it asks you that on the test, make sure you're specific to the actual question. Okay, so what's my domain here? So it's not X, it's T, right? So T is an element of the reals. T is what? Between two things. What is it between? Yeah, 0 and 5. And my range? 0 and 100. Is that what everybody got? Okay, and what is my rate of change equal to? So, but it's minus, right? Yeah. So this is minus 20 kilometers per hour. And how did we get that? You could measure this. This is 100. This is 5. And I divided it, right? And I got 20. And because it's going down to the right, it's negative, right? You don't have to show any work. You can just give me the answer, right? Any questions there? Okay, continuing on. We can find intercepts algebraically. I'm trying to see what, because you can't really tell what that is. You could guess, but you can't really tell what that is, right? You could tell here what that is, but the X you can't. So remember I was saying there was something characteristic about the intercepts that if, for instance, if the Y-intercept's 5, what do we know about the X? It's 0. And if the X-intercept is 2, what do we know about the Y? It's 0. Okay, so that's how we're going to do this algebraically. So when the graph intersects the x-axis, y equals what? When it intersects right there, what's the y coordinate? 0. So that's how we're going to do this algebraically. We're going to substitute y equals 0 and solve. What are we subbing it into? Y equals 2x minus 3. So do you see? We're taking the 0 for the y and we're substituting it in. So then we get 0 equals 2x minus 3. Move the 3 over. We get 3 equals 2x. So x equals 3 over 2. Or 1.5. You can see that's 1.5. Makes sense, right? Okay, when the graph intersects the y-axis, what do we know about that? X is 0. So although we can see that it's -3, let's solve for it, right? Y equals 2x minus 3. So this time we're substituting 0 into the x. So we get y equals 2 times 0 minus 3. What happens when we multiply by 0? Well, this whole thing goes to 0, right? And so then what do we get? Y equals -3. And we already knew that was going to happen because I could see visually it crosses at -3. Okay? So algebraically, if you can't tell graphically, you can do it algebraically by just solving pretty basic algebra steps. So when the intercepts are integers, it's more efficient to use intercepts to graph rather than a table of values. So we can use the intercepts to graph a linear function. To find the y-intercept, substitute x equal to 0. To find the x-intercept, substitute y equals 0. So this is kind of a summary of what we just learned. So in grade 9, we learned to graph a line by doing a table of values. You go 0, 1, 2, plug her in, plot the points, connect the dots, bam. So now we're going to learn some fancy stuff in grade 10. The first method of graphing a line is with the x and the y-intercepts. So you find the x-intercept, you find the y-intercept, and you just connect the dots. Pretty fast. Watch this. So to find the x-intercept, what do? We set y equal to 0, right? So if y equals 0, we're going to plug it into y equals minus 2x plus 6. So 0 equals minus 2x plus 6. Move the 6 over, we get minus 6 equals minus 2x. Divide by -2, what do we get the x-intercept to be? 3. So I put a point on 3 on the x-axis. So that's what it represents right there. Do you see that? Okay, so now how do we find the y-intercept? That's where x is 0. So if we're going to plug that into there, we get y equals minus 2 times 0 plus 6. What happens when we multiply -2 times 0? This whole thing goes to 0. And then we add 6, we get y equals 6. So that will be on my y-axis at 6. And then what do? We have 2 points. Connect them. I got a nice ruler, right? Connect the dots. Do you see? And the last step is to put arrowheads on. So does everybody see? That's a new fast way of graphing a line. We use the x-intercepts and the y-intercepts and we connect them with 2 points, right? What do you think about that? Faster than doing a table of values, right? Okay, let's try the next one. Is this the next one? Oh no, we have this here. Just randomly, we're matching a rate of change and a vertical asymptote. Okay, which graph has a rate of change of 1 and a vertical intercept of 8? By just first glance, they both have a vertical intercept of 8, right? Does everybody agree? Both of them have a vertical intercept of 8. Right there and right there. Okay, so which one has the rate of change of 1? I hear B. So this one is going, if I go from this point to this point, this one's going up 2 over 2. Do you see? That would be a rate of change of 1. What does this one have? This is up 4 over 2. So this is a rate of change of 2. So do you see this one would be the one? Yeah? Okay, keep going. Which graph has a rate of change of 1 and a vertical asymptote of, a vertical intercept of 9? Do they both have a vertical intercept of 9? Yeah, so that's not how we're going to tell. They both have 9 as their vertical intercept. So now you got to figure out which one has the rate of change of 1. It's actually B as well. So let's just, so rate of change, this one would be a rate of change. If I'm going from here to here, what's this rate of change vertically? What's this rate of change right here? Huh? 9. And what's this rate of change here? 3. So what's my rate of change? 3. And then here, do you see I'm going, if I just measure that and that, you see I'm going from 9 to 12, which is a change of 3, and from 0 to 3, it's a change of 3. So do you see that's a rate of change of 1? Okay. So we're going to use intercepts to sketch this and a third point. Why would I want a third point? If I have an X-intercept here and a Y-intercept here, why would I want a third point? Yeah, if the third point's way over here, you did something wrong. If the third point ends up being somewhere along that line, you know you did it right. So it's up to you if you want to do the third point. If it asks you to do it on a test, then you have to do a third point. But it's, like I said, you could just do that for a checking system. Remember to find the the Y-intercept, you set X to 0, right? So my equation is right here. Y equals negative X plus 5. So you put 0 in for X. What do we get for a Y-intercept? 5. So there's my 5. Yes? To find my X-intercept, that means Y equals 0. So 0 equals negative X plus 5. So what does X equal? X equals positive 5 as well. I feel like I'm going really fast here. What do you want to pick for a third point? You should pick something easy, right? 2? Okay, so when X equals 2, I would have picked 1, but that's okay. Y equals negative 2 plus 5. So what do I get? 3. So that means I'm plotting 2, 3. And is that right on the line? Do you see why the third point justifies that you did it right? Okay, then we take a ruler and we connect the dots, and don't forget to do what? Arrowheads. Yeah, arrowheads would be a an error code. So it's saying mark points at 5 on the y-axis, 5 on the x-axis, and at 2, 3 is how I got the other one, right? Okay, any questions on quick way of graphing? Whoops. There's another page, isn't there? Oh, that's just that. Why is finding a third point helpful? And what did we discover the third point was good for? Yeah, justifying it is correct. Remember, if I have a point here and it makes a triangle, then it's not linear, right? All right.